Let's talk about transformations now. For this discussion, we will utilize this example as our parent graph. And what we did when we talked about transformations is we distinguished between outside the parentheses, like these values you see here, and inside the parentheses, like you see these two here. Remember, when we were dealing with inside parentheses, we were dealing with horizontal changes, like a horizontal shift or a reflection about the y-axis. For our outside parentheses, we dealt with a vertical shift or compression or a stretch or a reflection about the opposite axes, right? And so some examples of each one of these forms is taking our parent graph. For a vertical shift, we will see a function like log base 10 of x with a plus 2 on the outside. And what that plus 2 will do, will shift our graph up 2 units. For the second one, we will see values on the inside of our log function. So like log of x minus 1. Remember, when we're inside, we kind of move in opposite directions. So we'll be moving to the right 1 unit. For a vertical stretch or compression, for example, I'll take my log function, multiply it by a half. For a compression, by a factor of 1/2. A stretch will take a larger value, bigger than 1, like 2. Well, we'll double our log function of x, right? So we have a stretch by a factor of 2. For our reflections, either we will take log of negative x or negative log of x. So, out of all these transformations, which one will change our vertical asymptote? And that is a shift left or right, so a horizontal shift, right? So we will be looking for functions like log base x plus or minus some value inside. This will be the only type of transformation that will adjust our vertical asymptote. So now, let's take a look at this function right here. This is y equal to log base 3 of 5 times x plus 3 minus 2. The only thing that's going to change our vertical asymptote is what's inside the parentheses, right? So this will be the only thing that will change our vertical asymptote. I'm just going to write VA for vertical asymptote. It will also change our domain. Since there's a relationship between vertical asymptotes and domain, let's go ahead and add that fact. We'll find it all together. And domain is what's inside the log. Remember, this is not multiplication. So, since there's a strong relationship between our domain and our vertical asymptote, we'll kind of find them side by side. So, for our domain, right, the only thing we can't take the log of are negative numbers, so can't take log of a negative number or 0. And so what we want is we want that inside that we highlighted above to be positive, so greater than 0. And then we solve the inequality. Subtract 3 from both sides. I get 5x is greater than negative 3. Divide both sides by 5. And I want x is greater than negative 3/5. And where a vertical asymptote happens is right at that same value where the domain kind of like breaks up, right? So what we do is we set, where does our domain kind of break apart? Right at 0, and then after that all the negative values. So right at that one value. Again, solve for x in the same way that we did off to the left, and we get x is equal to negative 3/5, right? So we see a nice strong relationship between the vertical asymptote and the domain. And our domain in interval notation since we commonly like to do that, is all real numbers bigger than 3/5, negative 3/5, so negative 3/5 to infinity. For the range, with all log functions, won't change, will always be negative infinity to positive infinity. Let's look at a couple more transformations. Go ahead and move on. Let's do this page together. Below are some equations with 3 transform functions. We won't work in our groups. And we also won't be including any end behavior. But we will, in fact, write in words the transformation and give a nice little sketch of the graph. So let's start with number 1. Right, we have 2 transformations if we look closely. I have this plus 2 and this minus 1, right? So the minus 1 will move graph down 1, and the plus 2 will shift, since it's on the inside, it's going to move horizontally, opposite direction, 2 units. All right, so for our transformation of our second one, I'll leave the third ones for you guys to explore. The only thing that's going to change here is this negative value, right? This is going to be a reflection. If you need to look back at your table, go for it, right? But any point along that is positive, right? This is saying negative outputs, so any negative outputs are going to bring them down here. So we have a reflection or rotation about the x-axis. All right, let's get into the graph. So I am going to address this from a transformation standpoint. So let's start by identifying our parent graph, and then we'll use what we know to give some information about my transformed graph, right? So my parent graph for this function, let me write it really quick. Our transformed graph is f of x equal to log base 3 of x plus 2 minus 1. Remember, we just kind of eliminate the addition, subtraction, multiplication, any of these extra values. So my parent graph is going to be log base 3 of x, right? So we start by identifying that base, which is 3. Fill out some key points. So remember, those key points are 1, 0, b1, so 3, 1, 1 over b, so 1 over 3, negative 1, and we have a vertical asymptote, always vertical asymptote at x equal to 0. So for our transformations, right, let's talk about key points. I like to apply all my transformations at once. So this point 1, 0. How is this plus 2 and minus 1? Remember, let us do it to all of them. I'm going to do it to all of them at once. I'm just creating a little bit of space so I can fill in those values, right? Because this minus 1 is going to change our output. So we're going to subtract 1 from all of our outputs. This plus 2, remember, we're going to switch the sign inside, change input. So minus 2, minus 2, minus 2. So I get the point negative 1, negative 1, 1, 0, 1/3 minus 2. We could just use whatever fractions we like. I'm going to use a little mixed fraction, so negative 1 and 2/3 minus 2. And our new vertical asymptote, remember, since it is an x value, I am going to subtract 2. So I get x equals negative 2, right? Or, you could do like we did on the previous page. So x plus 2 equal to 0. Solve for x, and you'll get the vertical asymptote, right? We have a few different approaches we can take with these graphs. Put it all together on our graph. I'm going to draw both my parent graph and my transformed graph so we know how to kind of work with either approach. Here is my parent graph. There's my vertical asymptote. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's plot some points. 1, 0, 3, 1, negative 1, 1/3. Connect the dots. So here is my parent graph. For my transform graph, I'm going to keep up colors, right? I'm going to shift my vertical asymptote over 2. I'm going to shift all these points over 2 and down 1. Should line up nicely with those points that we found, right? So I have the point, we got negative 1, negative 1. 1, 0, kind of in that same spot. And then, negative 1, 2/3, negative 2. I'm just going to draw a rough point in the general area. Not looking for perfection here. Get that standard shape and be sure not to cross that vertical asymptote. And there's your transformed graph. Now, there's a few different approaches you can take with these graphs, right? You could deal with the parent graph like we've been doing. We've got an exam coming up on transformation, so I want to make sure we're feeling okay, being consistent in our tactics that we're using, plugging in values. You can definitely utilize your different skills as you work through these problems. But let us do number 2. The function that we were working on was g of x is equal to negative log of x, right? So for my parent graph, that is your standard log of x base 10. Remember, no base written, it's base 10. Key points: 1, 0, b1, 1 over b, negative 1, except for b I plugged in that 10. Vertical asymptote at x equal to 0. For my transformed graph, right, putting a little negative in front of that log is going to take each one of these key points, let's list those out, and it's going to change their y value. So the point 1, 0, I get to tack a little negative in front of the y. Some points it won't do a lot to, right? So let's list them out. 10, 1, 1 over 10, negative 1. I'm going to take the opposite of all of these, and I get the point 1, 0, 10, negative 1, 1 over 10, positive 1 now. My vertical asymptote is still x equal to 0 because, as you notice, we didn't change any of those x values, right? And then we'll see it kind of on the graph, right? So here is the graph of our parent function, right? I always start that vertical asymptote. Let's get some points labeled in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Positive 1, negative 1. Parent graph 1, 0, negative 1, 1/10, and then 110. Right up here. Connect the dots with a smooth curve. And now we're going to flip our graph over, right? So we can see how this point won't change. That's that point 1, 0. That makes sense. Our vertical asymptote isn't going to change if we move things around that axis. 10, negative 1. right? That point's going to flip down here. This point's going to flip up here. Right, and you can really see that nice rotation or reflection.